Pleasant day, all viewers. My topic is about stereolithographic apparatus, SLA, which is in short form. It's a 3D printer which helps in an innovative approach towards the future of prosthodontics. So, we are living in a world of digital technology where it is possible to create a 3D model with the help of a intraoral scanner in a patient's oral cavity without any energy expenditure to take an impression and all the laboratory steps to be followed. So we are converting all these programmings into the milling machine and we are fabricating the processes. So this is what the world we live in. So coming to the development of CAD/CAM in dentistry, so it began with the help of Duret and Preston, who first established this CAD/CAM technology in the year 1970s, and it was followed by the work of Moorman in 1980s, which led to the development of CEREC, which we know nowadays. 3D printers. So the term 3D printers encompasses several manufacturing technology that builds a material parts layer by layer. So that is the most important designing of this 3D printer, and it has more advantages when compared to CAD/CAM. That is, it is helps in material selection. There are various some materials available. Surface finish is better, durability and manufacturing speed and cost effective. There are a lot of types, and what we considered first on fusion deposition modeling, which is FDM, and followed by stereolithography. So coming to fusion deposition modeling, it is an FDM printer functions by extruding a plastic filament layer by layer. So what a fusion deposition molding is, here you can see there is an extruder in this design. Okay, here a filament of material has been inserted, and after the heating process has been done, it comes out of this print nozzle and it builds it layer by layer. So we have designed this VAC 3D printers, and with this FTM technology we have done 4 versions. So first version, here we have, it is modified with acrylic framework. With here you can see the extruders, and this is the tooth which we are trying to build. It's just a model, a dummy model, and followed by which we enhanced it with the help of a solid aluminum profile body, which is version 2. Third, we wanted a little bit of a desktop model. We need to carry it, and it should be easy for us to carry. So we tried off a desktop model, and the last version 4, which is in process, is the 3D printer with the extruder, which is supported with 3 arms. You can see the 3 arms here, which are attached to the vertical post arranged in the triangle shape. So coming to the stereolithographic apparatus, so the topic of interest, so it excels at producing parts with high level of detail, smooth surface finish, and tight tolerance. So in FTM we had a little bit of a rough surface, and so we went for this SLA, which had better detail and smooth surface finish. So here the designing is, you can see this is the resin tank, and here we have the light or laser source, and from that laser source you have a display, and the display, each section of the layer which has been sliced with the help of 3D oral scanning will be here, it will be seen, and automatically the resin will get cured in that area. So this is also layer by layer curing and additive technology where you are not going to waste any material. So there are two types. First is top down and next one is bottom up. So top down is nothing but the z axis moves from top to the bottom, and here it is from the bottom to up. So top to down, here the laser will be over the top, the light source, whereas bottom up it's going to be below. So what we are going to see is the bottom up SLA 3D printers. So this is the VAC SLA version 1 which we have designed. You can see this is the SLA type. So here we have used Raspberry Pi. Okay, this is the motherboard and CPU when you compare it to the desktop or laptop, anything you have. So this is the Pi 4 Model B, which is a quad core and 4 GB RAM. These are all the specifications which we used for a SLA. And here we have the LCD display with controller. This is the display and this is the controller. We have used only HD, where even 2K and 4K is available. And this is resistive touch control, and this is just for a, just we need to know how much of a finish we get with the help of this HD display. Furtherwise, we can extend the process by using 2K and 4K displays. So here you can see this is the LCD display controller, and you need a UV light source. We used a UV light source. You can also use a laser type. We found it easier to use this UV light source. So above this will be the display, and a 3D scanning will be done and it will be converted into a milling process. And here what will happen is the model will be sliced into thousands or n number of slices, and each slice will be displayed over this controller, this display controller. And what will happen is that line alone, that layer alone will get cured, because that is where your UV light is gonna pass through. This is the SLA framework, where you can see this is the Z axis, this is the threads where the Z axis moves ups and down, and here you can see this is the build plate. Okay, so here you can see this is the resin tank. Here we are having the curable resins here, and below which will be the display. So what will happen is every slice will be uh, shown here, and what will happen is that area of the slice alone will get cured, and the build platform, it will be attached to this build platform, so it can remove a layer, each layer by layer, so that it moves ups and down for each layer to get processed. This is the light polymerized resin which we use, which is acrylocure. So here it is divided into castable and non-castable. So we have used a castable resin. So what we have tried here is we have just tried a metal wax pattern framework. So what we have done is after this a casting can be done, and we are just not gonna have any pouring of cast or wasting of any other materials, all these like hardener or anything. So we are directly skipping all the steps, and we are going for casting procedures with the use of this SLA 3D printer. So this is the model which we have printed from the cast. With the help of lab, we had the 3D modeling which has been done and been transferred to a G2 box, which is the software which we used. Even nano DLP can be used, and we have fabricated this. So if you can see here, here you can see there's a slight part. This is the first layer which we have done here. It's purple in color, you can see. And this is the final one. It took around 1.5 hours to for it to get finished. So 4 unit, a temporary bridge. So thank you. For any other queries, you can contact us. This is just in the trial stage. Hope we'll meet again in the future. Thank you.